Hello, everyone, and welcome to Precalculus. Today we're going to be combining sections 4.2 and 4.4, which is the study of the unit circle. So far you have learned how to think about trigonometry in terms of a triangle. So if I put theta down here in this corner, this side is considered opposite, this is adjacent, and this is always the hypotenuse because it's across from the right angle. If I were to put my theta up here, this would be considered opposite and adjacent, but hypotenuse doesn't change. So the unit circle offers a different way to think about trig. For some people, this is much more helpful, and for some people, they just like their triangle and they understand opposite and adjacent and hypotenuse. So on the unit circle, we can think of sine as the y value of any point on the circle divided by the radius. So let's just pick this point right here. This angle is 30 degrees. And if I were to take that point and transfer it into a triangle, this point has value x, y. So that means that this distance right here is my x distance. And this height right here is my y. And this is still the hypotenuse, which we're going to call r because it's the radius of the circle. And they call this the unit circle. So it's a single unit, so it's 1. So for consistency, all the hypotenuses are going to be 1. So even if I were to draw, say, this one over here, you can see that this hypotenuse is still 1. And it gives us a way to look at all the trig functions on the same scale. So now, instead of saying that sine of 30 is opposite over hypotenuse, we can say that sine is opposite over hypotenuse, as in y over r. And since r is equal to 1, you can just say that it's equal to y. So some people like thinking about them in terms of y and r and x and r and y and x. If you're one of those people, then maybe this will be helpful to you. I'm actually not one of those people. But it is how several people think about the unit circle. What I want to use the unit circle for is to explain how we find trig functions in different quadrants. All of the triangles we've drawn so far have all been, in essence, in quadrant 1. We've never done anything in a different quadrant, and the unit circle is fantastic for figuring things out in different quadrants. So first of all, we do need to label our unit circle. I can't recommend enough that you pause your video and see if you can recreate all the parts of the unit circle. I will show you again how I do it. Pi 6 and 5 pi 6. This is one more, so it's pi 6 up, but then this over here is pi, so this would be one less than a whole pi, so it's 5 out of 6. And then this one, which is the same, see how those are the same? And then this one is the same, would be 7 pi 6, because it's one more than a pi, and then 11 pi 6. So go ahead and see if you can do all those. I'm going to fill them in. Pi fourths, 3 pi fourths, one less, 5 pi fourths, one more, and 7 pi fourths. This one would be pi thirds, one less would be 2 pi thirds. This is going to be 4 pi thirds and 5 pi thirds. Our main quadrantals, which means right on the quadrant, is 0, pi halves, pi, which we've already filled in, and 3 pi halves. Now we do need to also put them into degrees. I personally think radians are easier, but you have to be able to do both. So this is 30 degrees, and then this is going to be 150. So the way you can think about it is if you can memorize these 3, 30, and then this one's going to be 45, and then this one's going to be 60. I'll show you a little way to remember them. So if this is 30, and you know that this one is 5, 6, this is 30 times 5. So 30 times 5 is 150. 30 times 7 is 210. 30 times 11 is 330. So I don't know if that helps you or not. So for 45, you could do 45 times 3, but a lot of people can't really do 45 times 3 in their head, so that's not very helpful. But the good news is that all of these angles are the only ones that end in 5s. So we have the 45, the 135, the 225, and the 315. And then for the 6s, we can do the same thing as before. We have 60, and then 2 times 60 is 120. 4 times 60 is 240. 5 times 60 is 300. And then this is 90, 180, 270. And this is still 0. 0 is the only one that doesn't change, whether it's in degrees or radians. If you do go all the way around the circle, it's 2 pi, which is the same as 360 degrees. Okay, so we did the unit circle in the last video. If you need to rewatch that, you can do that. But now we've filled it in real quick. And I really want to talk about the triangles in different quadrants. So let's just do the 30 degrees, and I think that that'll help you see it. So let me get my pen back. 30 is green. Let's make it just a little thicker here. Okay, so take a look at this triangle. I'm going to just tell you this ratio. This is a ratio of 1 to 2. That's a problem because the ratio of sine is 1 to 2. But because we're on the unit circle, somebody is always going to call this side 1. This is always going to be 1, which means I'm going to have to call this side 1/2 and this side square root of 3 over 2. So that way, sine of 30 degrees, and the 30 is actually in here, but I can't write them all in here or they'll start to get cluttered, so I put them on the outside. So sine of 30 degrees is 1/2, but 1/2 to 1 is the same as 1 to 2. It's the same. Now watch this. Let's say I go all the way over to 150 degrees, or pi 6. When you draw the triangle, even though technically 5 pi 6 is this angle right there, when we're doing a trig function, we always go down to the x-axis. That's the triangle you're looking at. So if you're at 150 or 5 pi 6, you're looking at this triangle. Well, look at these two triangles. Their proportions are exactly the same. So even though this angle was 150, we can still consider the 30-degree angle. So we call that a reference angle. I'm going to refer to 30, which means if I know sine of 30, I also know sine of 150. It's also going to be 1/2, 1/2 to 1. And if I know sine of 30, I also know sine of 210, because I'm going to refer to the 30 because it's the exact same size triangle. So if I were to make an angle at 210, I'd go way over here and then draw it. But when I go to figure out the trig function, I make the triangle using the x-axis. Therefore, if you're making a 210-degree angle, I can refer back to it as if it were 30 and get the exact same answer. Sine of 30 is equal to 1/2. Sine of 150 is equal to 1/2. Now, interestingly, though, sine of 210 is negative 1/2. Any idea why? Because now my opposite side, my y value, remember you're looking at the y over the r. Well, the radius is always positive, but the y is now down. I'm down in quadrant 3, so the y is negative. And then last one, sine of, so I'm going to go to this 11 pi 6, or 330 degrees. Oops, not 333, 330 degrees is going to be also 1/2. And is it positive or negative? Well, because I'm going to, if I go all the way around to get to this angle, even though that's where 330 degrees is, I'm still just going to draw it right here. It makes like a bow tie, the four that are connected. And I'm going to refer to it as 30 degrees. But because it is not 30 degrees, it's actually 330 degrees. It's over here, which means it's negative, because this is a negative 1/2 as I'm going down. So let's put those concepts together now in your notes. But I wanted you to see it on the unit circle. So a reference angle. When you are given an angle in quadrants 2, 3, or 4, you need to determine the reference angle, which is the angle in quadrant 1 that has the same value. So 7 pi fourths. So if I go back to my unit circle and I quickly, let's see, erase all of these guys, right? I don't want to erase you don't have to draw on this. You can just watch. Your goal is to understand this section. So just watching here would be okay. So 7 pi fourths is way over here, right? I go all the way around to get to it. But when I actually draw it as a triangle, I get to go from 7 pi fourths. So there's my 7 pi fourths. There's my radius. But I don't actually draw that big angle. I need to make it into a triangle. So you always go to the x-axis, not the y-axis, always to the x. So what angle measure is this? It's exactly the same as pi fourths. So the reference angle is pi fourths. Now, in case you haven't already figured it out, what's really cool about radian measure is that finding the reference angle is as simple as looking at the denominator. The reference angle for 2 pi thirds, pi thirds. The reference angle for negative 5 pi 6, it doesn't even matter that it's negative. Still pi 6. Even something like 21 fourths, which has gone around and around. That's 8 fourths, 8 fourths, and then 16 fourths. So 21 fourths is just like spinning around the circle, but the reference angle is still pi fourths. The reference angle for this one, no matter how complicated it is, still pi thirds. And the reference angle for this one is pi thirds. Let's just do one more so you can see it. If you get it, you can skip this little part. So 4 pi thirds, again, I'm going to erase the one that I have there. So 4 pi thirds is here on my unit circle. So if I were actually going to draw it, I would go all the way around. But when you're making your triangle, you need the y value and the r value and the x value. And you always make the triangle touching the x-axis, not the y-axis. So this angle, which was 4 pi thirds, is exactly the same size as the pi thirds. See? Pi thirds. And this angle, exactly the same. So the reference angle is pi thirds. For degree measure, this is why kids don't like degrees as much. It is a little bit harder to figure out, but there's going to be a little chart you can put in your appendix if you're in the CP class. And that is, well, if you're in quadrant 1, there is no reference angle. You're already in quadrant 1. So theta is the reference angle. Nothing to do. But if you get something in quadrant 2, so given theta, whatever it is, you figure out that that theta is in quadrant 2, you can do 180 minus theta, and that will give you the reference angle. So you do have to be able to figure out what quadrant it's in. But you should be able to do that because 180 is right here. So if you get something like 170, you should know that it's in quadrant 2. This is 270, and this is 360, and this is 90. So if you get an angle between 180 and 270, then you can do theta minus 180, and that will give you the reference angle. And if you get something between 270 and 360, that means you're in quadrant 4, and you can do 360 minus theta, and that will give you the reference angle. So there's your little formula chart. That's how you find the reference angle if it's in degrees. If it's in radians, it's a piece of cake. A little bit more work for degrees. So let's practice that. So I'm at theta is equal to 300. So that's somewhere in this quadrant, right? So if I went all the way around, that would be 300. But I actually would draw my triangle here. So I'd be referring to that little angle. And what is that little angle just right? Just like 360 minus my 300. Oh, I can refer back to 60. I can base my problem on 60 degrees. 172 is in quadrant 2. It's not quite 180, so it's still right there. And so my formula this time is 180 minus 172. So it would be just like 8 degrees. And think about that. Well, let's draw that one so you can see it. So here's 180. So 172 is pretty close to 180, right? There's 172 degrees. But if I make it into a little triangle, what's left? 8 degrees. That's what makes the triangle. So that's the reference angle. Ooh, a negative angle. So negative just means that it's gone counterclockwise. So this is definitely a little bit harder now because now I need to go negative. This is negative 90 and negative 180, negative 270, negative 360. So I'm going to go this way. So if I go negative 125, I'm somewhere in here, which means that I need to find what this angle is right here. So definitely a little bit trickier. There's no formula for this. Personally, I would just figure out what it is in the positive direction. So if you add 360, okay, then you can find the same angle in a positive way. So you can use the formula. Okay, so in other words, don't try and get a whole nother set of formulas for your negatives. For the few times that a negative happens, just go ahead and make it positive. And you can do that by adding 360. So negative 125 plus 360 is 235. So this is really just 235. Where is that? That's in this quadrant. So 235 minus 180 is my formula because I'm in quadrant 3. Roman numerals for quadrants. And so my reference angle, 235 minus 180, is 55. 55 degrees is the reference angle. Are you starting to like radians more? Most people start off not liking radians, the fractions and the pi. They're more comfortable with degrees, but I guarantee you everything we do in trig will be more complicated with degrees. And if you take calculus, there are no degrees in calculus. We do everything with radian measure. So you just really have to learn it here. Okay, same thing. This is negative. So I'm going to add 360. In other words, I'm going to kind of go around the circle. So wherever 420 is, let's just say it's here. If I go around the circle exactly once, I'll be in the exact same spot, but I'll have a better number. So 420 minus 360 is negative 60 degrees. Okay, so I'm right here. I'm at negative 60. Do you even need a formula? No, sometimes you can just use your head. If you're down here at negative 60, what reference angle is it? Positive 60. Forgot to box that one. So positive 60 is the reference angle. Okay. So we did one little problem with sine, and I was explaining how sine of 30 is 1/2 to 1, and on this side, 1/2 to 1. But when we got down here, sine was negative 1/2 because the y value in this direction is negative. And same thing over here. So you could recreate this every time, but that would be a lot of work. So instead, we make a sine chart, and this will just help you at a glance know if the answer is going to be negative or positive. So first of all, all the functions are positive in quadrant 1. All positive. In quadrant 2, just the sine is positive because it depends on the y value, and the y value is positive. But cosine is adjacent over hypotenuse. So as soon as you move into quadrant 2, do you guys see what happens? You have a negative x value. The adjacent is in the negative direction, so cosine is not positive there. Cosine is going to be positive for these two. And then tangent is going to be positive here because it's opposite over adjacent. So it's actually two negatives, negative x and negative y, and that ends up making it a positive. So we don't usually clutter our chart with this, but just as an aside, the ones that match could be considered. So cotangent goes with tangent, secant goes with cosine, and cosecant goes with sine. But most people just think about the three main ones, sine, cosine, and tangent. So I'm going to tell you a great little way to write this on your paper super fast, and that is cast. Interestingly, a lot of teachers throughout the country will call this all students take calculus, or I've heard all students talk constantly as a little mnemonic device. I never really liked either of them, so I asked my classes years ago to think of a good one. And a young man named Corey Hess, who this year we have Julia Hess in our class, her older brother, came up with a great mnemonic. He said, let's call it forecast, because you use it to predict, new pen, because you use it to predict the sign, just like a forecast predicts the weather. You're going to use it to predict the sign, whether it's positive or negative. So you start in quadrant 4, and then you write the word cast. Forecast. I thought that was extremely clever. I would love to see that one make it across the whole nation. So you are going to have to memorize different trig functions unless you're in CP. Technically, you're allowed to have an appendix, but I have to tell you, we're going to use these so often, that would be like pulling out your calculator every time you needed 2 times 3. It's going to be annoying if you don't memorize them. So you are going to want to memorize these. So sine of 0 is 0. Sine of pi 6 is 1/2. Sine of pi 4ths is the square root of 2 over 2. Sine of pi 3rds is the square root of 3 over 2. Sine of pi halves is 1. And just to show you how cool this is, you don't write this, but just look for a second. This is actually the square root of 0 over 2, the square root of 1 over 2, the square root of 2 over 2, the square root of 3 over 2, and the square root of 4 over 2. And the other ones just simplify. So if you're ever really stuck and you need to make this chart, it's just square root of 0, 1, 2, 3, 4 over 2, which is really cool. And it just shows the progression. Think about what that means. That means at pi 6, which is 30 degrees, we can write the degrees above it. 30 degrees, 45 degrees, 60 degrees, 90 degrees. As you're going along, that means that this ratio is 1 to 2. But as soon as you make it a slightly bigger angle, pi 4ths, now it's square root of 2 to 2. And then when you make it an even bigger angle, pi 3rds, now it's square root of 3 to 2. I just think that that's absolutely fantastic. And where's pi halves? Pi halves is 90. So there is no triangle. You can't make one because you're going straight up and down. If you're at pi halves, then you're looking at the y value and the hypotenuse, so it's just a 1-to-1 ratio. So anyway, really cool background of how those numbers, have such a beautiful pattern. But seeing as you might not care about the pattern, you can just memorize them or write them down. Cosine is going to have the opposite pattern for reasons that we'll talk about later. So 0, 1/2, square root of 2 over 2, square root of 3 over 2, and 1. Tangent is sine over cosine, so 0 divided by 1 is 0. 1/2 divided by the square root of 3 over 2 simplifies to the square root of 3 over 3. Square root of 2 over 2 divided by the square root of 2 over 2 is just 1. If you divide these two, you get the square root of 3. And you can't divide by 0. So this one does not exist. You can't do tangent of pi halves. Because tangent, remember, is opposite over adjacent. And if you keep making this triangle bigger and bigger until you're at the top, then it's the hypotenuse, but over 0. You just can't divide by 0. And then sine of pi is 0, and sine of 3 pi halves is -1. We'll talk about those more in section 4.5, but you can just write them down for now. This is -1 and then 0. This is 0, and again, does not exist, or you can write undefined. All right, I know I have been pouring into you a whole bunch of information, but now I'm going to put it all together, and I'm hoping that it'll make sense. So sine of pi fourths is just going to be on your list. You see it, square root of 2 over 2. But if you're given sine of 3 pi fourths, your first job is to determine the reference angle. So you're like, oh, it's pi fourths. So you can think of this as just pi fourths. But I don't want you to forget that it's actually 3 pi fourths. So make sure you're thinking about the forecast. Make sure you're thinking, okay, 3 pi fourths, because it's 1 less than a whole, is up here in quadrant 2. And once you have those two pieces of information, you can get the answer. So sine in quadrant 2 is positive, and sine of pi fourths is the square root of 2 over 2. 5 pi fourths has a reference angle of pi fourths also, but it's in quadrant 3. And in quadrant 3, only tangent is positive, which means by default, sine must be negative. But since it's pi fourths, know the value in quadrant 1, it's still just square root of 2 over 2. Sine of 7 pi fourths is over here in quadrant 4, and its reference angle, nice and easy, is just pi fourths. So I know it's square root of 2 over 2, I just have to figure out if it's positive or negative. But since it's sine and only cosine is positive here, it's going to be negative. Now, just to show you how much harder it is in degrees. In degrees, so cosine of 30, remember 30 is the same as pi 6, and cosine is the square root of 3 over 2. So 150 is in quadrant 2. Remember, you have to know this is 90, this is 180, so you have to know where it is. So it's in quadrant 2, and looking at my little forecast, cosine isn't positive there, so I know it's going to be negative, so I determine to the sine. Now the reference angle, these, by the way, these don't have to be in any certain order. The reference angle, this is that annoying one, right? So it's going to be 180 minus theta. So it's going to be 30 degrees is what I'm going to refer to. And on my chart, cosine of 30 is square root of 3 over 2. 210 is over here in quadrant 3. So I'm in quadrant 3. According to my forecast, cosine is negative in quadrant 3. It's only positive in 1 and 4. And how do I get this reference angle? I do theta minus 180. So 210 minus 180, the reference angle is 30. Once I know it's 30, I can use my square root of 3 over 2. So that's why knowing this chart is so important, because every single reference angle points you back to here. Last one, and I'm sure you can guess what quadrant it is and what reference angle it is. So 330, this is 270, and this is 360, so it is in quadrant 4. Cosine is going to be positive in quadrant 4. See the C? That stands for cosine. Remember, this tells you where things are positive. So you do need to look at your other chart. Your appendix is going to be key this chapter. Your other chart, and this one is going to be 360 minus theta. So 360 minus 330 is a reference angle of 30. And cosine of 30 is square root of 3 over 2. You might see if you can do the last one on your own, but of course I'm going to do it for you. So tangent of pi thirds, going back to my chart, tangent of pi thirds is square root of 3. So now, because these are all pi thirds, the reference angle for all of them is pi thirds, which means the value for all of them is going to be pi thirds. The only thing you have to do is to determine the sign by figuring out what quadrant it's in. So 2 pi thirds, you could look at your unit circle every single time. But again, let's look at this pattern. Anytime the numerator is 1 less than the denominator, you're in quadrant 2. Anytime your numerator is 1 more than your denominator, you're in quadrant 3. And every time your numerator is significantly higher, specifically times 2 minus 1, times 2 minus 1, times 2 minus 1, you're in quadrant 4. And of course, if the numerator is just 1, 1/3, 1/4, 1/6, you're in quadrant 1. So I can use that fact to finish this up. I can sit there and say, oh, 2 pi thirds, that's going to be in quadrant 2. 4 pi thirds, 1 higher, so it's in quadrant 3. 5 pi thirds times the 3 times 2 and subtract 1, that works. So I must be in quadrant 4. And now I make my forecast. I start in quadrant 4 because it's called the forecast. And I see that they're all positive here and tangents positive here. So in quadrant 2, it's going to be negative, and tangent in quadrant 3 is going to be positive, but back and forth it's going to be negative again. Okay, so before we try these, let's go ahead and make the 2 pieces of information that we need. One is our forecast. So I start in quadrant 4 and I write the word cast. This is going to tell me where things are positive or negative. And I do have some degrees down at the bottom, so I'm going to go ahead and make that chart, which is going to be nothing here but 180 minus theta, theta minus 180, and 360 minus theta. This is how I get my reference angle if there's degrees. If there's not degrees, then you're set. So it might actually be helpful to get all the reference angles. This is going to be just pi thirds. This is just going to be pi fourths. Ooh, 4 pi, we'll talk about that. This is going to be pi thirds. No matter how, look how complicated it's getting. This is just going to be pi 6, pi 6, pi fourths, pi thirds. Isn't this fantastic? Okay, so 210 is clearly bigger than 180. So 210 minus 180, or you can look at your unit circle. It's on there. This is going to be 30 degrees. Cosine of 300, that's also on your unit circle. Or you can use this, 360 minus 300 is going to be 60 degrees. And 135 also on your unit circle. But I kind of have them memorized just because all the 5s are related to the pi fourths. But that means they're all with the 45. So there you go. You have all your reference angles. Now you need to figure out what those values are. So get your chart out. I don't know if you can, which paper it's on, or if you've already transferred it to your appendix. But cosine of pi thirds is 1/2. Tangent of pi fourths is 1. We're going to keep skipping number 3. Sine of pi thirds is square root of 3 over 2. Cosine of pi 6. I'm just looking at the chart. Cosine of pi 6, square root of 3 over 2. Sine of pi 6, 1/2. Ooh, cosecant. All right, we'll go back to those. So once you have the reference angle, you're able to get the value, and then you just need to know if it's positive or negative. So where is 4 pi thirds? Now you do have a unit circle that you can have with you during your quiz if you're in CP. However, it's 1 higher in the numerator, so I know that it is in quadrant 3, and cosine is negative in quadrant 3. Tangent of 5 pi fourths, again, 5 over 4 is 1 higher, so see here's pi. So that's like 4/4, right? 1 whole pi. So 5/4 is in quadrant 3, but tangent's positive in quadrant 3. All right, I guess we'll finally do number 3. So where's 4 pi? So not everything's going to fit in this nice little mold, right? So there's 2 pi. And if I go around again, there's 4 pi. So it's the same as 0. And cosine of 0 is 1. So sometimes you have to do a little thinking. Not everything is going to fall into this perfect pattern. Number 4, 5 pi thirds. So it's definitely in quadrant 4 because it's almost all the way around. All the way around would be 6/3. That's what would make 2 pi. So I'm at 5/3. I'm not quite all the way around, but sine is negative. Only cosine is positive in quadrant 4. 13 pi 6. Uh-oh, now what? So 13/6, if you're trying to figure it out, remember that this is 6/6 because it's 1 whole pi. And then if you go all the way around, you're at 12/6, right? Isn't that 2? So 12 pi 6 is 2 pi. That's 1 all the way around. So what's 13 pi 6? You've gone around just a little extra. Okay? Quadrant 1. Battery. Got it. So you're in quadrant 1. Everything's positive in quadrant 1. Sine of negative 5 pi 6. So again, you can use your unit circle, but negative means I'm going to go in this direction. But I didn't quite go a whole pi, right? A whole pi would be 6/6, so I've gone 5/6, so I'm in quadrant 3. And sine is negative in quadrant 3. This is going to take some practice. If you're like, oh, I'm not going to get this. It just takes practice. Honestly, in school, we'd be making flashcards. I literally would give you class time and construction paper to make flashcards of all this information. It's the only way to get good at it. All right. Cosecant is the flip of sine. So just do sine. So sine is of pi fourths is the square root of 2 over 2. So I need to flip that. So I'm going to make it 2 over the square root of 2. So if I flip it, I get 2 over the square root of 2. But you can't leave that radical in the bottom. So I'm going to multiply the top and the bottom by the square root of 2. And I get 2 square roots of 2 over 2. And then those cancel. I just get square root of 2. So here's what I want you to do. I want you to go back to this one, and I want you to write down in a different color what the flips are, because you do not want to do that every single time. So if you have cosecant, okay, this is not going to exist. You can't flip 0. This is going to be 2. This is going to be the square root of 2. We just showed that. This is going to be 2 square roots of 3 over 3. That one's going to be hard. If you flip 1, it's still 1. You can't flip 0. And if you flip -1, it's -1. For cosine, that is the flip of secant. So if you're asked for secant, you can use these little red ones we're about to write in here. You don't really want to make a whole chart, but you can just write them in the corners here. So secant, if you flip 1, you get 1. If you flip this, just so you guys don't have to actually do the flipping, it's a lot of work. It's going to give you 2 square roots of 3 over 3. If you flip this, you'll get the square root of 2. If you flip 2, you'll get 2. You're not going to be able to flip 0. Secant at pi halves does not exist. -1, and this does not exist. Cotangent at 0 does not exist because you can't flip 0. If you flip this, you just get the square root of 3. If you flip 1, you get 1. If you flip this, you get the square root of 3 over 3. And if you flip this, this actually comes out to be 1. I know that that's a little confusing right now, but we'll talk about what that makes. Oh, not 1, 0 later, but you can go ahead and fill it in your chart. So in other words, I don't want you to have to do all this flipping stuff. That's a lot of work. So you can just have those on your chart. All right, we do still have to figure out if it's positive or negative. So 7 pi fourths, where is 7 pi fourths? It's a big number. It's probably in quadrant 4, right? And it is. 7 pi fourths, you can either look at your unit circle, or you can think, well, all the way around would be 8 fourths, 2 pi. So this is definitely in quadrant 4. Oh, cosecant's not on there. Well, you have to know that cosecant goes with sine. This is sine and cosecant, they go together. So in quadrant 4, they're negative. So my final answer is negative root 2. I know some of you are maybe feeling a little overwhelmed. We're going to do another one just like that. This time I'm going to do secant. So what am I thinking about? I'm thinking about cosine and flipping it. So cosine of pi thirds on my chart, cosine of pi thirds is 1/2. So if I flip it, it's going to be 2. That wasn't so bad, right? It's going to be 2. I do still have to know what quadrant I'm in. 2 pi thirds is over there in quadrant 2, and cosine and therefore secant are negative in quadrant 2. Okay, let's do some with degrees now. Tangent of 30. Again, we put degrees at the top of your chart, so you can just use that. Tangent of 30 is the square root of 3 over 3. And that's just our reference angle. We're actually thinking about 210, which is in quadrant 3, and tangent is positive in quadrant 3. Cosine of 60, we've already found the reference angle. So cosine of 60, 60 is on your chart as pi thirds, and the answer is 1/2. Where is 300? 300 is way over here because this is 270 and this is 360. So 300 is in quadrant 4, and cosine is positive in quadrant 4. And tangent of 135. So we already figured out the reference angle is 45, which on your chart, you can go back and look. Tangent of 45 is 1. And 135 is in quadrant 2, because this is 180 and this is 90, so it's in quadrant 2. And tangent is negative there. Think about your forecast. Only sine is positive there, so it's -1. So much to remember. So you got to find a system that works for you, an appendix that works for you. You can do this. I know you can. Of course, not every angle in the world, when people are building things and designing things, not every single angle is going to be 30, 45, 60, or 90. There's going to be pi eighths, there's going to be pi fifths, there's going to be all kinds of different angles. So you're only required to memorize or to have on your chart and give me exact answers. Sometimes your book will say, give the exact answer. That's because they want you to say the square root of 3. They don't want you to do it on your calculator. If you see exact answer, that means no calculator, because your calculator is going to have to round. But if you have anything that's not on your chart, by all means, type it in. The only thing you have to be careful of is the mode. So make sure that your calculator is in radian mode. Make sure that it's in degree mode. And then back here, now you need to go back to radian mode. So you might want to do 1 and 3 first. Okay. I'll do the first one for you just to make sure that you get one right answer. But then I do want you to do the next 2 on your own, and just to make sure that you're typing this in right. Okay. So cosine, I know you have to wait for me, of pi divided by 8. I'm literally just typing into my calculator. Comes out to 0.924. So go ahead and do those next 2. I'll look for them when I check your notes to give you your 10 out of 10. Show me that you did them. Okay, last section. We're almost done. You can do it. This is just doing it backwards. It's just really making you more familiar with your chart. So it says, when is cosine the square root of 2 over 2? So you go back to your chart and you find the square root of 2 over 2 and you're like, oh, at pi fourths. You can say 45. I'll take either answer. So you just fill that in. Oh, at pi fourths. Is there any other time? There is. There's always going to be two solutions because of forecast. You gave me the quadrant 1 answer, but where else is cosine positive square root of 2 over 2? In quadrant 4. So what is pi fourths in quadrant 4? Now you're doing reference angle backwards. It's going to be 7 pi fourths. If you're still enjoying degrees more, that would be 45 degrees or 315 degrees. But for me, if I'm going backwards, this is even easier because once I know I want quadrant 4, I double this number and subtract 1, and I don't have to figure out the degrees, which is challenging. So now, which two quadrants is cosine negative in? So I still look up square root of 2 over 2 on my chart, and I know it's going to be something fourths. You can actually go ahead and write that, but the numerators can be different based on what the value is. So where is cosine negative? Cosine is negative in quadrant 2, which is 3 pi fourths, 1 less, and quadrant 3, 1 more. Not too bad, right? You should really pause the video and see if you can do the next few on your own, but of course I'll do them for you. So for when is sine equal to the square root of 3 over 2, I go back to my chart and I find it and I see it's at pi thirds. So I write down pi thirds. And I know there's two answers, so I'm going to write pi thirds twice. And sine is positive in quadrant 1, and according to my forecast, quadrant 2. So what is pi thirds in quadrant 2? 2 pi thirds. You can either get that by looking at the unit circle or by knowing that it's 1 less. When is sine negative square root of 3 over 2? Again, I know it's pi thirds. You can write that part down. But now I need my forecast. I need my answer for sine to be negative in quadrant 3 and quadrant 4. So we're doing the reference angle backwards. What is pi thirds in quadrant 3? 4 pi thirds. The numerator is always one more than the denominator because there's 3 thirds and you're going a little bit further. Another third, 1 and 1/3. And in quadrant 4, double it, which would be 6 minus 1 is 5. Or you can look on your unit circle. Okay, we can't do secant. So as soon as you see secant, you got to just change it. When secant's 2, cosine is 1/2. So you're welcome to do that. If you have, you might say, oh, I know secant. Secant is 2. But always be thinking in terms of sine, cosine, and tangent. So when secant is 2, cosine is 1/2, which means we're at pi thirds. So I'm at pi thirds. I'm going to write pi thirds twice. Actually, I'm just going to go ahead and write it all 4 times. The question now is just which quadrants. So where is cosine positive 1/2? In the first quadrant, they're all positive. That stands for all. And cosine is also positive in quadrant 4. How do I represent pi thirds in quadrant 4? As 5 pi thirds. I double it and then I subtract 1. So where is cosine negative? Cosine is negative in quadrant 2 and in quadrant 3, because that's where sine and tangent are positive. So in quadrant 2, it's 2 pi thirds, and in quadrant 3, it's 4 pi thirds. All right, we did a lot today. This was a hard lesson, in my opinion. You have a lot to learn. Really practice, maybe make some flashcards, make a great appendix. But most of all, know that you can do this. Have a great day.